You've probably used Axios. I mean, it's one of the most popular, most trusted tools in a web developer's toolkit with tens of millions of downloads every single week. But for a little while, it was compromised. It was turned into a weapon in a really sophisticated supply chain attack. Okay, let's get into it and break down exactly how this happened step by step.
So where does a story like this even begin? Well, it's not with some crazy line of code. It starts with a person. This quote from the project's maintainer, wow, it just says it all. This wasn't just a technical hack, it was a deep, personal deception. They used trust as their way in. It's a huge reminder that, so often, the human element is the first domino to fall.
So, the big question is, right? How does something so trusted turn into a weapon, a digital Trojan horse? We're going to follow the breadcrumbs from the initial deception to the malware itself, and finally, to who is pulling the strings.
All right, let's start at the very beginning, the breach. You know, the attackers didn't just brute force a server. They manipulated a person. This first phase is all about the social engineering trap. Okay, so check this out. The way they did this was just so methodical. It all kicks off with a simple, seemingly innocent Slack message that then leads to a Teams call where the attackers build this false sense of friendship and trust. Then, pretending it's all part of a collaboration, they convince the maintainer to run a program on his machine. And you guessed it, that program was malware. Its only job? To sniff out and steal his NPM account credentials. Those are literally the keys to the kingdom, what lets you publish code to the official registry, and it worked.
So they've got the keys, what's next? Well, now it's time to actually weaponize the Axios package itself.
And look how fast this all happened. I mean, they did not waste any time. As soon as they got the credentials, boom, they published new malicious versions of Axios. But here's the really sneaky part. They didn't put the malware directly into Axios. No, they added a new dependency, a harmless-looking package called plain crypto.js, and that's where they hit the payload. Made it way, way harder to spot.
So you're probably wondering, wait a minute, aren't there supposed to be checks for this stuff? And you're right, there are. But by using the maintainer's legitimate stolen keys, the attackers could publish directly to the NPM registry. This let them completely sidestep all the usual security checks, the code reviews, the automated testing, the whole CI/CD pipeline that's supposed to catch this stuff. They just walked right past the guards and put the malicious code straight onto the shelves.
All right, so the malware is out in the wild. But of course, it couldn't stay hidden forever. It wasn't long before security researchers started noticing something was off. They detected the compromise and began the painstaking work of decoding exactly what this malware was built to do.
So the first thing they found is what's called a dropper, and the name is pretty much perfect. Think of it like a spy who gets inside the castle. Its only job is to get past the gates, find a good spot, and then open the door for the main invading army. It's the first small piece of code that brings in the much bigger, much nastier payload. And this is where we see the whole attack chain laid out, piece by piece. A developer unwittingly installs the bad version of Axios. Then a post-install script, that's our dropper, automatically runs. It phones home to a command and control server run by the attackers. And that server responds by sending back the real weapon, a seriously dangerous piece of spyware called a Remote Access Trojan, or RAT.
And get this wasn't some clumsy one-shot deal. No way. The command and control server was smart. It would check the victim's operating system and then deliver a custom-built payload specifically for macOS, Windows, or Linux. The level of detail here just shows you these attackers were serious, well-funded, and aiming for developers on every major platform.
Okay, so the payload is delivered. The spyware is on the machine. But what was it for? What was the endgame here? What was this Remote Access Trojan actually designed to do?
A RAT? Yeah, it's pretty much as nasty as it sounds. It's a type of malware that gives an attacker a secret backdoor into your computer. They have full control. They can see your screen, they can log your keystrokes, and most importantly, they can steal any file they want, all without you ever knowing they're there. It basically turns an infected computer into a mole, a digital spy.
And this rat was a thief with a very specific shopping list. It was hardwired to hunt for the absolute crown jewels of a developer's machine. SSH keys, credentials for cloud services like AWS and Google Cloud, more NPM tokens, Kubernetes config files, even sensitive data from your web browser. We're not talking about small stuff here. These are the keys to the entire castle.
And that's the key takeaway, right? The ultimate target wasn't just some random developer's laptop. It was the whole CI/CD pipeline, the automated heart of modern software development. Those environments are absolute treasure troves of the exact kind of secrets this rat was looking for, making them an incredibly valuable target for espionage.
Okay, so We've seen the what and the how. Now for the final piece of the puzzle, the who. After all this analysis, who do the experts believe was behind this whole operation?
Well, after some serious digital forensics, Microsoft's threat intelligence team connected the dots. They attributed this incredibly sophisticated attack to a group they call Sapphire Sleet, which is a state-sponsored threat actor with known ties to North Korea. Yeah, this wasn't just a couple of hackers in a basement, this was a state-level operation.
And all of this, it brings us to a really uncomfortable question, one that affects pretty much anyone who writes code today. The Axios attack is a stark reminder that almost all modern software is built on a foundation of open source code. We implicitly trust hundreds, maybe thousands of these packages in our own work. So after seeing how easily that trust can be twisted and weaponized, it really makes you think, how do you really know that the code you depend on is safe?